Stefan, welcome.
Welcome, thank you.
Yeah.
All right, so I'm just gonna
do you want to set up the demo a little bit? There's a lot here on this slide.
Absolutely.
Yep.
So as you know, it all starts with data and discovery. So we've got a lot of data out there. It feels like the bad guys are winning because of the sheer volume of information.
Machine versus machine.
Machine versus machine, a lot of data. We got to pull it all together. We have to run our powerful AI and analytics in order to be able to find those bad guys. And then we need to be able to automatically respond with speed and efficiency.
A couple of things that jumped out as we were architecting Titanium X and our detection and response product is how volumes and algorithms, right? We're talking here, and what we're about to see live is we're processing 2 billion events a day.
2 billion events a day.
Yeah,
that's reality.
Between friends, that's a lot of events.
Yes.
Right, so 2 billion events a day. And then the math, our incredible engineers and our mathematicians working on this are big brains. And we have a ton of algorithms. Out of fun, we put one up there that we're going to use today, one of the algorithms.
Absolutely. We've literally spent over a decade crafting hundreds of algorithms that I'm happy to share with you today.
Stefan, take it away.
All right. So let's do my biometrics login here. So I'll just use my fingerprint here.
So use biometrics to log on?
That's right. And as I said, it feels like the bad guys are winning. There's a lot of data. There's a lot of information out there, but the good guys just can't keep up. So let's start with reviewing the data that's being consumed by the system. So here's our 21 billion events stored that is the result of 2 billion events a day. And we've got 3 data sources streaming in with high velocity. In this case, we have endpoint data coming in from Microsoft Defender. We've got identity data coming in from Microsoft
So the
Entra ID.
composable security part?
Absolutely. And we've got OpenText network alerts coming in from OpenText Bricata. Right? So coming in at 50,000 events per second, that's the 2 billion
That's machine versus machine.
So
you can see we've been turned on since 1010, and you got 21 billion events.
That's
here.
right. That's right. And
we're using our Vertica technology underneath.
That's how we're scaling.
Yep.
That's right. So this is a lot of data. So what you need is a system that turns it into something that's actually actionable, so you could tell you where to look and what to do. And so we'll start with the incident dashboard. This is where a typical SOC analyst might start their day. And if I just filter by the most severe, highly critical incidences, I'll see that the most important incident is this one right here that involves a user named Jana Lynch. So there's something up with her account. And there's information here about some sort of process communication, a piece of malware called Hydra. So I want you to remember those two things, Jana Lynch and Hydra. They'll come back. Yeah. But if you look at this almost looks like magic. Like, where did this come from, right? And so
our algorithm behind the scenes matches this up.
Exactly right. So what we're going to do is we're going to just go to the Explore tab, and we're going to just peel back the curtain a little bit and show you how we've let machines do the work. So this is where our detection algorithms come in, and they've been doing all of this work for us, including Jana Lynch, the highest risk user in our system, and an AI-generated, aviator-generated summary of exactly what happened. So in natural language,
so the machines and the algorithm produced Jenna, in this case, as a high-risk user.
Absolutely. Yep. And you have a simple-to-understand explanation of exactly what happened with Jana's account, including an explanation of how these exact techniques are mapped to the online MITRE attack database, this community source advanced repository of every single
sort of the encyclopedia, the active encyclopedia.
And it's explaining it in context of the behavior. The machine has already been doing a lot of things for us, like understanding normal behavior patterns, automatically stepping up authentication because this is a high-risk user, and it's keeping track of all of the underlying low-level details that correspond to the attack, including allowing me to quickly see the smoking gun. Yep. So in this particular case, the smoking gun is...
I don't mean to interrupt, but one of the things I get away is just how active you are in the user interface here, right? As a security operations analyst or part of a CISO team, I mean, you're active in the software.
I know.
Yeah, I find that fascinating.
I know. It's what's
we
really
didn't rehearse this, but it continues to come to life for me where just how interactive you are with the software.
Well, what's nice about this is it's not reactive. You're not reacting to an incident that got reported later. This is the machine generating things to you in a predictive manner. So it's fantastic. So this is an example of a behavior indicator of compromise. So this tells you exactly what the smoking gun was. And this is to your example at the beginning of this talk. These are the not one, not two, not three, but the 4 individual pieces of that needle that were automatically stitched together by our AI to tell you exactly what happened, even though they were at different points in time.
It's not just the needle in the haystack. It's the needle's been broken into 4 pieces, put into 4 haystacks. You're going to find the 4 parts and bring them back.
That's right.
Yeah.
And again, if you're in security, you got to trust but verify, right? So what are the underlying raw events out of the 21 billion events that actually led this secure machine to be compromised? So I can search on Hydra, and I can very quickly in real time essentially get this feedback that tells me exactly what was typed in on the command line to install this piece of malware into an otherwise secure system. I can look at this and say, okay, it was a command injection, and that's what the vulnerability was. So what do you want to do about this, Mark? Well, let's go back to the incident, and this is where the...
So it was ingest, it was detect, and then there's a whole plethora of responses you could do.
Exactly. So now on to the R of XDR.
Yeah.
And we've got a huge diversity of...
I don't know why the industry doesn't call it IDR. Ingest, detect, response, but they put the X there for ingest.
Well,
it's a different topic.
It's the industry. We do have all of this fantastic, like literally hundreds of open integrations with our partners to be able to do things like quarantine the file, lock down the machine, create incident tickets, and obviously integrations with our own products to be able to initiate a remediation process. And you can also take those individual actions and automate them into sort of scripted playbooks that can then run automatically on your behalf. So it's fantastic. So here's the best thing about this story, Mark. This is not demo data that we just created for this presentation. This actually happened. This is a real incident. Of course, we changed some of the details to protect the innocent, but this actually happened in one of our customers who was a design partner, and it would have been completely unnoticed, buried in the data, if not for our algorithms and AI.
They avoided being on the left-hand side of that chart.
Absolutely.
Yep, Stefan, thank you very much.
Thank you so much.
Pleasure.